All right, welcome to The Explainer. Today, we are going to crack open the machines that pretty much run our entire world. We're going to look right past the screens, past the keyboards, and really understand what a computer truly is. Okay, let's get into it.
Now that probably sounds like a weird question, right? But the answer, it gets to the very heart of what we're talking about today. See, both the super complex device in your hand right now and that appliance doing your laundry, they share a fundamental identity. At their core, they are both computers.
So what does that really mean? If you strip everything else away, a computer is just any machine built to do three simple things based on a program or a set of instructions. It takes in information, it does something with that information, and then it gives you a result. It's a way broader definition than most of us probably think about.
And this lays it out perfectly. Input, processing, output. Your keyboard, that's input. The chip inside that's calculating a spreadsheet, that's processing. The monitor showing you the final numbers, you got it, that's the output. Every single computer, from a tiny little chip to a giant server, follows this exact same three-step dance.
Okay, so we've got the basic blueprint down. Now let's meet the family. Because let's be real, not all computers are created equal. They are highly specialized, they're designed for completely different jobs, everything from controlling one little robot arm in a factory to running, well, the entire internet.
What's super interesting here is how we can categorize computers by their purpose, by what they do. First up, you've got your process computers. Think of these as the dedicated specialists of the industrial world, like a robot that does one thing and one thing only, like paint car doors all day. Then there are embedded computers, and these things are everywhere, managing one specific task inside a bigger device, like the little chip that actually makes your digital camera work. Then you have what we all know, general-purpose computers, your PC, your laptop, the jack-of-all-trades designed to do a million different things. And finally, you have servers, the powerhouse machines working behind the scenes, serving up websites and data to all of us.
And the sheer range within this family is, well, it's just staggering. On one end, you have this tiny, totally hidden, embedded computer that just does one simple thing over and over again. And on the complete other end of the spectrum, you have a supercomputer, a massive machine taking up a whole room, using all of its incredible power to solve just one monumental problem, like forecasting global weather patterns. Both computers, but built for wildly different jobs.
Okay, so we know what they do, but what are they actually made of? Let's pop the hood on a regular old computer and see what's really making it tick. What are the essential organs of this machine?
Inside, it's kind of like an ecosystem where every single part has a critical job. It all plugs into the motherboard. That's the central nervous system of the whole operation. The actual thinking is done by the processor, the CPU. Its short-term workspace is the memory, fast RAM for whatever you're doing right now, and ROM for basic startup instructions. Then you have the specialists like the graphics and sound cards that handle what you see and hear. Your storage drives hold onto your files for the long term. And of course, the power supply is the heart, pumping juice to every single component.
So you can have all the right parts, but how they're organized, the actual architecture, that's what really determines how a computer thinks. It's not just about the physical stuff. It's about the logical blueprint that they all follow to work together.
Most computers you'll ever encounter use one of two main blueprints. The von Neumann way is the classic design. It uses one big pool of memory for everything, for both the instructions, the how-to part, and the data it's actually working on. The Harvard architecture, though, does things a bit differently. It keeps them separate. It has one memory for instructions and a totally different one for data. And the key thing here is, because they're separate, it can go grab the next instruction while it's still working on the current piece of data, which can make it faster for certain jobs.
So how does all this information get from the processor to the memory and back again? Well, it travels on something called the bus. And you can literally think of it like a superhighway system running inside the computer, a whole set of electrical pathways that shuttles data between all the different parts at unbelievable speeds. Now, data can travel on that highway in one of two ways. Parallel transfer, that's like having a massive 8-lane freeway, where 8 bits of data can travel all at once. It's fast, yeah, but you can imagine it's bulky and the signals can kind of interfere with each other. Serial transfer, on the other hand, is like a super efficient single-lane road, sending just 1 bit at a time.
And even though that sounds slower, it's way more reliable and less likely to have errors, especially over distance. And that's exactly why pretty much everything today, like your USB cable, uses this much more elegant, dependable serial method.
So when you peel back all those layers, what's the big takeaway here? The most important thing to remember is this. A computer is not magic. It's not some unknowable black box. At the end of the day, it's a beautifully logical system. It's a collection of physical parts, organized by a clear blueprint, all working together to follow that powerful, simple loop. Input, process, output.
And that's what brings us to the future, right? We started this whole thing by saying your washing machine is a computer, but that trend is just speeding up. As chips get smaller, cheaper, and more powerful, more and more everyday things are getting that ability to input, process, and output. So leave you with this to think about. As pretty much everything around us gets smarter, what's the next thing in your life that you think is going to become a computer? Thanks for watching.